Hello, we're going to be doing standard 1.2, which is on matrix representations of states. We're going to be doing problem 1.5 out of McIntyre, which states consider a quantum system described by a basis A1, A2, and A3. The system is initially in a state psi initial equal to I over root 3 times A1 plus root 2/3 times A2. And we should note that this state, this I here, just represents that the system's in its initial state, and it doesn't represent anything complex. And this I, it does represent the complex number I. And we're to find the probability that the system is to be measured in the final state, psi final, equal to 1 plus I over root 3 times A1, plus 1 over root 6 times A2, plus 1 over root 6 times A3. And we're going to be doing this using the matrix representations of these vectors. Because here we have a general quantum state, basically represented, the system's represented by the A1, A2, A3 basis. And we want to represent these two states, psi initial and psi final, using their matrix representations. And then we're going to be able to simplify the work. And this is going to be a good practice because we're going to continually do this to reduce the complexity of our work. Because as soon as we try and find probabilities and do other calculations similar to what we've been doing, when we have higher amounts of basis vectors and higher dimensional systems, using Brockett notation gets substantially harder and the arithmetic gets very complex really quickly because we're going to be taking a large amount of products with one another. But using matrix multiplication and using matrix representations, we can just take an easy multiplication between two vectors and it only comes into a small amount of math. So to do this, we note that we're going to represent A1 with the vector 1, 0, 0, A2 with the vector 0, 1, 0, and A3 with the vector 0, 0, 1. Once we have that, we can just add these states across and we get that psi initial can be represented in this basis as I over root 3, root 2/3, and 0, and psi final can be represented in this basis as 1 plus I over root 3, 1 over root 6, 1 over root 6. And now that we have this, we can find the corresponding probability that we're looking for. And this is going to be done during the same process as before, but now we're just going to be taking the dot product of two vectors, which is just taking a row vector times a column vector, rather than using Brockett notation. So we have the probability is equal to the inner product of psi final times psi initial modulus squared. And here we just take the corresponding adjoint of psi final, which is 1 minus I over root 3, 1 over root 6, 1 over root 6 as a 1 by 3 row vector, times a 3 by 1 column vector, psi final, which is I over root 3, root 2/3, 0. And once we do that, we can just do standard matrix multiplication, and we get 1 plus I over 3, plus 1/3, plus 0. And now when we take the modulus squared, we just get 5/9, which tells us that the probability that the particle going through an analyzer coming out as psi initial, being measured in that state, and then later being measured in psi final, is 5/9. So thank you, and that'll be it.